Christina, the mic. You're muted.
Of course, why not?
It's a great start. It's a great start.
Welcome everyone to our after lunch break and our one of the most sought after sessions today about audio and video testing. Our speakers are Deniss and Adrians from Test Dev Lab, and I will not talk a lot about them. They will share what's most important to know. But audio and video testing, how interesting is this? So, gentlemen, it's you now.
Thank you so much, Christina. Yeah, we're very excited to be here. And we're here today to talk about audio and video testing. That sounds exciting. That actually is. And it's also interesting that it's quite a niche area of testing.
That's a pretty specific field of testing that we're doing right now at the moment, which is called audio and video testing, benchmarking to be exact. So
yeah, let's try to go ahead and deep dive, and we'll try to explain it as best as possible from our point of view. And we have multiple angles, and let's start with just a presentation here. And what are the usual services for audio and video testing and the capabilities that we have discovered? And we are actually having multiple projects. All in all, we have 150 people engaged in different audio and video testing services. So what the usual things that you can test with audio and video kind of test activities are video conferencing, obviously, the one that we're in right now.
Well, it'd be more live streaming, I think, right now, no?
Well, yeah, but also video conferencing is part of, so live streaming is part of, or video conferencing is part of live stream. And more like, live stream would be more like broadcasting. So video conferencing more here, I would say online meetings, correct? So yeah, live streaming, any type of live streaming. For example, game live streaming as well is quite popular nowadays, and
YouTube live streams, Twitch live streams, Twitch. Completely everything that's
video on demand. So that's anything like Netflix, HBO, Disney.
Again, YouTube platform again, because they have a lot of video on demand.
Sure, and audio streaming, AV platform SDKs. There are companies who create platforms for audio and video for different services, and SDKs are software development kits that can be implemented in other applications. And short form videos,
which are now gaining a lot of popularity in it.
Yeah, for sure. Like what we have, TikToks, Reels. Even Netflix now released the quick laughs or fast laughs segment. So those are the applications, again, that AV testing capabilities area is concerned with. And what types of tests there are, at least what we have experienced, and there might be others in time that we discover, but these are the core and main ones. Audio and video quality of experience testing is for both manual and an automation hybrid. We'll go through the process a bit later. And obviously there are also fully automated setups that are mostly there for regression testing. For all those previously mentioned app developers, if they want to know if their new code broke the old one. And then next we have
the advanced network simulations, where we can simulate various real-life conditions on site. So, for example, you have headed for an airport where there's a lot of people and there's a really bad bandwidth connection.
Congested network.
Yeah, congested network. So we're doing completely everything.
Yeah, we're also doing profiling and then kind of repeating that as a simulation We even have now a bus with mobile setups that is able to go through different areas where you have bad signal, like a foresty area, and then moving from the forest area to the field area, and how that changes the behavior of the application that's under test. Yeah. So what else we have?
We have screen sharing.
Yeah. So for screen sharing, quality of experience, also different metrics are being used to analyze that.
But we're going to explain the metrics later.
Yeah. For the next things as well, we're not just only interested in how good of a quality audio or video is
For the user side, but also from the hardware side.
Exactly. If those somehow correlate as well together, if you're on a handheld device and the app is not tuned to those mobile devices, it might be an awful experience. The network is sufficient, but just because of high picture quality or just super fluid video, it's the device is not able to process it. So we do need to monitor GPU, CPU, RAM, maybe even I/O metrics on the device itself. Then, as additional services, is virtual background testing. Right now, we have on multiple video conferencing apps the possibility to enable this feature, change different backgrounds. And if you have noticed, if you have especially different accessories on you, like glasses or headphones, caps, anything, or just really vibrant or high contrasting colors, on or background, or your shirt, or like any clothing items, then it might be pretty difficult for the virtual background software to work. And we have algorithms that determine the overcropping or undercropping, basically how good is the virtual background software doing.
Exactly.
And then there's dominant and active speaker detection tests. It means if the sound actually matches the that active speaker who is engaged at that point, and whether the switches happen quickly or there's some lag or it doesn't happen at all.
Okay, let's head to the next slide. Yep.
Yeah.
So what we're doing, we're testing on real user devices. We have various mobile phones, desktops, so we can do it on Mac, on Linux, on Windows.
This is super crucial, right, Adrian?
Yep,
I think
exactly.
If you're doing, obviously all of those app developers are already doing some in-house testing, but most of them don't have the variety of the devices that we are mentioning here: mobile, web, desktop, different combinations. And this is where such companies that we work for come in. We have the devices from previous projects, also functional testing projects, and we can definitely use those. And for new engagements, we can also procure newer devices and test those.
The main thing is to understand if on low budget phones and on high budget phones, the app going to perform the same way it does on better devices. So, yeah.
Yeah, and another thing to mention is that we use those physical devices with virtual users. We can spin off different cloud instances with a UI test automation. But for that purpose, we use our own in-house built tool that spins up those virtual users, calls into meetings, or opens up streaming apps or anything like that to actually simulate the high load situations. And then we monitor the physical devices, what's the app behavior there, using our metrics that we're going to talk about in a second. Yeah, before that, we'd like to go through testing process. It's almost the same as, probably functional testing and everything else. It starts with the test preparation, test planning, and It basically means we talk to the customer, look at the specifications, requirements. We build that statement of scope of work at the very beginning. Then it goes to the actual, scope of work. Obviously, we have those. We have to build and make sure to prepare physical setups with the physical devices, with all the specialist gear.
The crucial part is obviously network infrastructure, which we need to create separately and dedicated from the office.
Yeah, so foundation is already there, but just for you guys to understand what's crucial is to make sure that there are no interferences between any of the connections, any of the feeds, network feeds that come into the devices. So for that, we have engineers, networking engineers, who are making sure that
and constantly
that
monitoring if everything is all right.
Yeah.
So next phase, what we have is the test data capture phase, where actually the manual testers, the testers are creating and joining the live sessions and recording the data. Let's say it like that. Yeah, Deniss.
Yeah.
And
well, in automated tests, obviously this is performed automatically using UI scripts, and then after we get all this captured data for audio, for video, for network, this is sent over to data processing servers. We have data processing specialists who make sure that this processing runs smoothly, that the outputs match the inputs. Even after that, we have additional step of validating that the data is precise, it's valid, concise, nothing's missing, and we have the correct correlations, and we don't have any false positives, false negatives. And the last step, I'd say most
interesting part
most
of this all is to create actually a different variety of charts to show for each metric that we get. We show benchmarking reports to see how actually the app performs regarding itself or the other competitors.
Yeah, that's the interesting part you mentioned, Adrians, is for those app developers to look at not only how they perform against themselves, but to look how they perform against competitors, how competitors are doing. And well, just recently, we were partnering with Zoom to get them compared to other competitors, and they have released a public report on that in their blog. This is the test setup. Yeah, we have both mobile devices, as you can see, and desktop devices. For mobile devices, we do have a special sender monitor that you see here on the chart. The sender device films that monitor, on which we play a very specific dedicated video with the markers. We'll explain what markers do a little bit later. We have special receiver and sender routers. So if we have multiple participants, we will connect each participant to their own router so we can control them fully. And we also have on the schema there an audio card for which we do an audio connection. We have loopback interface, so we can record both sender and receiver. And yeah, that's one of the most simplest and straightforward setups that we have, like for one-on-one calls here, maybe even for participant calls. So what are the metrics? Here we will go a little bit also maybe more technical. We'll try to
keep it high level as possible.
keep it high level. Maybe I'll jump out and show. Oh, yeah, actually, sorry, just jumping back to the test setup.
We can show actual images from the setups that we have on the premises. So, yeah.
Yeah, and these are a couple of setups. All in all, we have 50 plus already different setups and still growing. So these are the black boxes that we have, and we call them black boxes. It's like black box testing. a bit
None a bit different. No.
yeah. Yeah. So here we see the desktop setup. We don't necessarily need the black box because for the desktop setup we can emulate the camera. We actually feed in video directly to the virtual camera software. We use OBS for that, and yeah, then it acts like a camera, but we don't have any degradation of the actual source on the sender side. So yeah, we can see a couple of setups here with the mobile devices. This is some real test going on here. You can see also a
delay camera.
yeah, Logitech delay camera. So that camera actually captures both the sender and receiver, and afterwards in post processing we do get the latency between the sender and the receiver. So it gives us the possibility to show what is the
end-to-end latency.
Yeah, end-to-end latency
between receiver and the sender.
Exactly. Yeah, another setup. I'll just quickly go through some. Yeah, we have an engineer working here as well, thinking. Yeah. So different setups. These are kind of straightforward. We also had real device setups for like 20 devices. That's a very complex one. And yeah, I think
We can jump back to
yeah, I think you got the idea of it. But then let's continue.
Yeah, so regarding the audio and video quality metrics for the video side, we have different things. But the main video quality is full reference image quality assessment.
So let's also back up a little bit.
Okay, let's
like
go back.
higher level. So for video, what we can analyze?
We can analyze the video quality and we can analyze video fluidity.
Yeah, so image quality.
Yep.
And how smooth is the transition of frames
throughout the images, let's say like that.
Yeah, as we know, video is a sequence of images. And here, for image quality assessment,
we're using the full reference image quality assessment, VMAF, which is developed by Netflix. It's precisely tuned for our purposes. On the other side, we're using also a no reference image quality assessment, which is Brisk.
Yeah, and our in-house developed one, VQTDL. We have used Brisk in numerous cases before, quite widely, but due to its nature and how it was built, it wasn't as solid and as stable for our specific needs, for our specific testing activities. And yeah, we have an R&D department for audio and video testing, not only in Tesla Lab as well for other things. And as an output of research and development in this field, we got our own prediction algorithm. So what it does, it predicts the score, because full reference
actually takes the source video, which is sent, and the degraded one, which is received on the receiver.
So the good video and the bad video.
And they're completely compared together. And then we get a score assessment from 0 to 100, where 0 means that it's really bad, completely, you can't understand what's going on even, and 100 is the best score possible and the highest quality.
Right. And yeah, and for the no reference, we are interested in the image quality, but without the reference. So if we don't have anything to compare to, and that's actually the most wanted case here. Yeah. If you stream something, you most probably don't have the streamer source, so you would like to analyze under different network conditions how the app behaves, what's the quality.
Exactly.
And yeah, so this VQTDL is a deep learning mass prediction tool. Deep learning is like one of machine learning kind of these underpinnings, let's say. And We have a very sophisticated neural networks working there to actually predict the scores from 1 to 5. So we kind of emulate the mean opinion score prediction processes. So once we analyze the image quality in these both approaches,
we still have left the third one, which is subjective mean opinion score, where we take a group of people, put a video on, and they actually give opinion score from 1 to 5, and then we take the average out of it.
Yeah, so that's what we are trying to predict with no reference there. Yeah. Frame rate, that's about fluidity. What we do calculate is average frame rate, but captured on the receiver media. So we're interested in the, again, end user experience. There are other ways to capture frame rate, but we do it so that we're really sure that this is the frame rate that is on the end user side.
Also, from the frame rate, there appears to be freezes when the network congestion is really high. There are some stops, and that's what happens. We can get count of the freezes. We can get duration of those. Also, we can say precisely when how much time was passed between the freezes. Also, the total and average time of the freezes throughout the whole testing period. For example, if it's 3 minutes. Then we have a blurriness.
There's a particular. This is particularly critical. I should mention.
Actually, yeah.
Because if you get the frame rate, the average is not doesn't show the actual, like, what happens during the actual second, right?
Right.
So if half a second is slow or choppy or just freezes altogether, and the other in the other half of a second we can have the speed up. I don't know if you've seen such cases, but yeah, so it's just all of the packets are received at one point when the congestion is over, and then it kind of goes into the video. And that part, if we just look at the average frame rate per second, then we would see a normal situation. That's why we need to see specifically those freeze occurrences and map it together with the frame rate.
Yeah, so next we have a blurriness score. So it shows how blurry the actual image is. As we know, there's different type of artifacts can happen throughout the live streaming or throughout the video conferencing session. Sometimes you can see pixelization, let's call it like that. Sometimes it's much blurry, so we get actual score of blurriness. Next, what we can get is the video delay. One of the metrics, it's end-to-end latency, how much milliseconds, or if it's needed in seconds, to say from sender to receiver.
Sometimes it can be seconds.
Sometimes it can be seconds, yeah, for some applications. How long time it takes from sender to go to the receiver one. So next up, we have audio.
Yeah, and for video delay, I just wanted to mention that we already seen the video delay camera in the real setup that actually films both of the screens for sender and receiver. Yeah, right now we have to do it in pairs, right? So the same as for audio, we have to pair them and then measure between two participants, and then kind of have multiple pairs measured in the multi-participant call if necessary. Yeah, for audio, we have a couple of industry-wide terms or just names, which is Polka and Whistle. Polka is a licensed tool. So it's not open source. Well, you have to pay for it. And
unfortunately.
And Whistle is a Google developed one. It's open source. Everyone can use it. It's Polka is a bit more precise in our experience. Well, Whistle still usable, and comparatively, like if you just preference between the competitors, it's quite fine.
And next up, we have audio delay, which is basically works in the same way as video delay. We captured the sender audio, we captured the receiver audio, and we compare it to get the end-to-end delay. Then we have different various network metrics where we can get network consumption throughout the test, how much the application uses to get a good video quality and fluidity. We can get network latency, also the network quality score.
For network quality, Adrians, I just wanted to mention that under quality, we assume a jitter, packet loss,
and bandwidth consumption.
well, that kind of also is there, but for specifically quality is jitter and packet loss. If the app doesn't decode those streams, we can get for each stream like audio and multiple audio, multiple video streams from multiple participants. We can get that information.
Of course. So yeah, let's head to the next slide.
Just wanted to kind of
Mention the
close
last
down.
one.
Yeah, we talked about it, performance. So yeah, CPU, GPU, RAM. It's also necessary.
Possibility,
Yeah, and battery consumption tests we also do. So hook up power monitor to the actual device. It's not the same test specifically to mention because it would be just too much hassle. But you can have battery consumption tests as well, understanding how much battery drain is happening for a specific application. And yeah, before jumping into network control capabilities, just wanted to show you what quickly the concepts that we're working with here. So bandwidth is we can call it like the throughput, right? And the throughput is impacted by the kind of width of the channel, or we can think of a pipe, like a water pipe with a kind of smaller or bigger circumference, like diameter. And so the bigger the diameter, the more the water can flow. Here as well, the bigger the bandwidth, the more the traffic can flow. And that throughput of how much of traffic can flow is called bandwidth. It's measured in bits per second. If we lose some of the traffic, and that point of loss can occur in different gateways or routers, they are configured specifically to hold a necessary amount of data for in a specific point in time. And if they can hold a specific bucket of traffic just waiting to be sent out, they will throw them out, and it's called packet loss. So yeah, that's what we are talking about. And jitter, just for your again notion, is that the variance between the packets that arrive on time. So and the sequence of those packets that arrive. So if they are not arriving in sequence, then the app is waiting for the packet to arrive. So for example, if packets 1, 2, 3, 4, 5 is sent in sequence and received like 5, 3, 2, 1, then this is the situation where jitter will be measured. So how much time it took for the first packet to actually be received, and that is something which decreases and lowers the quality of the overall experience. Yeah. And quickly, just we can go through back the network control capabilities.
Yep. So what we can do is we can get the modified access points where we have full control of the network. We're getting the bandwidth limitations, the packet loss through the traffic shaping, TC set to be exact. We use it to fully control our environment. Also, we're using the TCP dump to get the network traces on the routers itself. Then we pull them from the routers towards our laptops and analyze them there.
And that's how we do network profiling.
Yep.
We have done one interesting case. We went to Brainstorm concert, and we did field testing, like more profiling to understand what's happening in real life networks. What is the impact of that on bandwidth, on packet loss, and jitter, latency. So yeah, that information is gathered specifically to have the intel to be able to reproduce such high load real network situations.
In laboratory, yep. So next we have real mobile network simulations, which is 3G, 4G, and brand new 5G.
Yeah, here we can split into two. One is having a 4G or whatever 5G router and route from the actual SIM data traffic. And the other one, yeah, we have actual SIM cards.
Well, yeah, we have this brand new thing where we actually take SIM cards, which is limited from the provider side already. We just put them in a phone, and we have, for example, 300 kbps for a particular phone on a 4G network. So yeah, next we have file testing.
Yeah, we
mentioned that.
Yeah,
let's go to the next slide.
Yeah, so here again, just what we already went through. We have different possibilities to do these type of testing, like sender and receivers. Simple use case: we send one video, we receive one video. On the multiple sender side, we send multiple media, so multiple videos. We can have one video with static foreground, static background, just maybe a moving bubbly head. And some of video can be really dynamic, high definition range videos, etc. And that is captured on also different receivers, and we can analyze those. And then we would have like just one sender, one video sent out, for example, and multiple receivers, like maybe a broadcast situation.
To understand, we can limit different networks for not only for the sender or receiver. We can do it advanced, like or we can, how to say, never mind.
Right.
I just want to say that we're doing burst packet losses as well as uniform packet loss on receiver, uplink and downlink. So that's more advanced approach.
Yeah, there can be multiple points of exit and entry, which can be controlled.
There can be places where we just limit the sender. We can be just limiting the receiver's uplink or just receiver's downlink. So it's a crucial part as well. We can just put limitation anywhere we want, and each limitation takes a new test scenario and a new path.
That's correct.
So yeah.
All right. Yeah, quickly about the reports. We have different types of reports. We have like in-depth slide deck reports, which usually is really something that partners and clients are really interested in. They want to see the findings. They want to see the conclusions. They even want to see recommendations, what they should do to actually enhance their app at certain scenarios. But then besides that, we have results portal APIs. Results portal, you can quickly visualize the data and draw averages, draw time series data. You can skip portal, of course, and go for API. So that's a really good way to feed the data to the clients, who want to see the results. And well, more simplistic way to show and send is the Excel sheets if they don't have, or they don't want to build anything to kind of access the APIs, or they don't want to use the results portal. Excel sheets or Google Sheets is something that works. And well, raw JSON files, just sending over the files, or they can access the files, and then those are all the types of reports.
So, and as you mentioned earlier, we have time series graphs, which is mentioned here as overtime series graphs, where we have a metric, for example, FPS on this particular right side. For each second, we have average out of 30 frames. And it goes on, for example, in this case, 180 seconds, which is the 3 minutes. And we can see each second's average fluidity.
Right, yeah, and we can get this these graphs, these types of graphs for different time series data. It can be for FPS, it can be for VMAF, S&P SNR.
Basically, any type of metric we have.
Yeah. And well, averages are good to quickly gain perspective on how good the app behaves on average in a certain test condition. Here is an example of unlimited network, how, for example, your app, meaning like if you're a client, how your app is behaving against others. In this case, it's frames per second. And again, this can be viewed from any angle possible. Well, for automation, obviously it's like end-to-end user experience testing boosted, because it's all you can get with manual testing, but just running 24/7, delivering the results all the time, regularly and systematically. And obviously it can be implemented in CI/CD pipeline. So this is obviously something every client who wants to have a continuous engagement goes for. Before jumping to Q&A, we actually wanted to show a real testing report, and even video. So if we look at,
if actually this conference happened on site and we had a real live test scenario which we planned, but so we have pre-recorded right now.
Yeah.
So I'm one of the audio and video test engineers.
Yeah. So here I'll just decrease the volume a little bit. But Adrians is the sender side. So we here we'll see on the other video we're in a Google Meet call, and here we don't see any degradation. So it's really the reference video of the good quality, and we can see the markers going crazy here. The markers, we actually use Aruco markers,
4x4,
4x4, 16-bit. They can hold up to 65,500 something data points, which helps us to actually decode each frame in a ID. Well, we
let's
can
say
identify,
to recognize which frame was the previous frame and which is the current frame from all these markers.
Yeah, so it helps us build the actual sequence if we decode the video into images. So we decode the video into frames, and then each frame is identified by these markers. And we also know the sequence. We know we can determine also the spatial we can create spatial understanding, right? So based off these markers, we can give a X and a Y coordinates for certain scripts and algorithms for them to actually get a certain area of evaluation. For VMAF is super important, and for other things as well.
I show the degraded one. So here's an actual Google Meet call, and what I did on my side was apply a limitation.
Not yet.
Not yet. You're going to see it in a moment. It's going to be at around 300 kbps, which I'll say the Google Meet performed quite well. So
yes and no.
Yes and no, yeah. So as you can see, it starts to stutter. It has frame drops.
No, it's
freezing.
And now we see image quality degradation.
Yeah, as I mentioned earlier, there was blurriness and pixelization. At this particular moment, you can see pixelization, and now the blurriness enters the stage as well. So it can multiple artifacts can combine. There can be color bleeding as well on the sides. You can see on my shoulders. So different type of artifacts can happen throughout the testing of the application.
Yeah, important to mention here as well in the video, if we replay it. At the beginning, we don't have any markers. And what Adrians does, he enables an overlay in OBS software where markers are played.
So let's get back. So we actually use a virtual camera for or particular this type of testing, where we go into the Google Meet, we change settings to virtual camera OBS, and then on OBS, I set these Aruco markers so we can determine the FPS and the region of interest for our VMAF and BRISC.
Yeah, so these are the videos. Again, we recorded the sender side, which is the reference, and the degraded side, which is the receiver. And here are the data, right? We went through different algorithms. We got our VMAF, PSNR, and SSIM. We got frames per second. We got VQTDL. We got freezes. And this is how it looks on the graphs. Then we have a moment where we don't have any limitation enabled. So on the 10th second, the limitation kicks
wasn't
in.
enabled yet,
Yeah,
and we can see the quality drops drastically.
yeah, we see frame rate drop like almost to zero, maybe some points where it tries to get up. And then when the app actually recognizes what is the situation with the network, then it picks up the frame rate, which is
It tries
the
to
good-
understand,
yeah.
it starts to prioritize video quality or fluidity or audio quality. So it has three aspects, and it needs to understand, okay, we have 300 kbps, where we shall divide this 300 kbps bandwidth to get the best user experience possible for our particular client or user.
So here in this particular test, we saw the image quality drop on the 19th second. And this is, it starts to drop already after 18th, and we can see that gradually decreases until it reaches the dip, and then it comes back again. So yeah, VMAF is a little bit more skeptical to that, and it tries to kind of
goes more into technical aspects.
Yeah. So that's also totally normal.
Yeah, I think.
And freezes we saw this is the graph. This shows the length of the freeze, the time of the freeze. So also really good kind of visual to understand what's happening at what point in time in regards to freezes.
I think it was quite insightful. Now let's head towards the questions.
Yeah,
we have around 5 minutes left, I think.
Yeah. Let's do the questions. I'll switch off the screen sharing. Oh, quite a lot of questions already came in. So question one from Alexandra. She's coming from satellite communications, also tested video and audio streaming in that networks. It's not easy to simulate real life network behavior. Do you gather some statistics? Use that in tests on most common network configs, delays, codecs, or testing is based on preset values provided by equipment you use? No, like we already,
That's a nice question.
Yeah, it's a really good question. Like we already discussed, we do gather different complexity of data and how we would like to simulate the network. And many times the clients themselves already provide that. So they have some type of statistics like what is the P95 of the user base for a certain region or for a certain segment, and they will provide us with that, and we enable. Also, like we discussed, we did some field test real life profiling. So based on profiles, we can also replay those certain conditions. We think, though, there are still many things that are possible out there.
Let's head towards the next question from Olga. In which domains such tests are required? Who are your customers?
Well, we can definitely mention Zoom now, but many of other customers we cannot mention. But you can imagine that throughout the last 3 years, with 100 people onboarded already in the AV department, there's quite a lot.
Well, the COVID pandemic hit hard on the video conferencing and on calls and remote work. So everyone who uses remote work, calling applications, everything that you can count it, where they need the testing, the benchmarking.
Yeah. So the next one is from Alexandra once more. Are all the tests you perform related only to software? Do you test hardware such as modems, routers, audio, video cards? We have done some hardware-related testing. So again, it's saying that test scenarios are defined, specific scope of work, and then we look at the hardware specifics, like we already discussed the performance metric area.
So next one, we have a question from Alexander again. Each coder has acceptable jitter, delay, packet loss, bandwidth parameters it can deal with. Do you test different encodings?
Well, sure we do.
Well, we do, yeah.
Well, on the SDK side, if the configuration allows, certainly that's part of the kind of configuration, SDK configuration testing.
And the request from the client side if we need to test VP8 codec or any other type of codecs. So,
yeah. So question from Olga. How are you switching 2G, 3G, 5G network? Just change SIM, or still you use receivers on the roof? Do you use different mobile operator for 3G, 5G? yeah, we do have certain specifications, certain requirements from the clients to use different operators with different senders or different receivers. And well, how do we switch? If the client is okay, we do it through a 4G router, then we can control all those situations and kind of not switch between the technology, obviously, but if we use real SIM cards, then we actually have to switch the SIM cards.
Yeah. And last questions, it seems that what could be done if network is not stable? We'll be able to improve the Microsoft Teams. That's a nice question. So to understand, we're not actually developing, we are benchmarking and giving the insights what could be done to improve the application itself.
But that's the question. What can be done?
What can be done? You can answer that one if you want to.
Well, yeah. What can be done? I think one of the primary things which are thought of is the bandwidth estimator, how well the app can understand the available bandwidth in the network in a certain situation in time. Is it adapting quickly enough? Because we've seen in variable bandwidth tests that an app drops the quality, but cannot go back to the quality level even if the network is available at that point. And also, I think the most peculiar or like most complex cases would be with packet loss, because
And you need to understand if you need
the
to
reason
send
of packet loss.
double the times the.
So yeah,
Oh, yeah.
there could be packet duplication. There can be packet resending, different things to battle that. But again, I think this is something that real, well, not real, but app developers are trying to understand and fight against.
Yeah. So that's it.
Thank you so much. Very much on time. Thank you, ladies, for your very insightful questions. I see you're sound engineers and video engineers. Very interesting topic. I haven't heard such an interesting testing topic for a while, because this is actually testing topic, a very quality engineering topic. Thank you, gentlemen. It was amazing. Thank you so much.
Thank you all. Thank you all
Have a
for
nice day.
joining, and Christina, thank you as well.
Yep.
We enjoyed it very much.
You too. Bye.
Have a